Greetings, everyone. Hope you are doing well today. This is our video for our day 2 of our Unit 1 Foundations for Algebra. So if you would get your notebooks out, and we have a unit divider that we'll have already put into our notebook. So that describes this unit, Foundations for Algebra. So just past that unit divider, our title for today is going to be Day 2, Variables and Expressions. So if you would get that title, jot it down at the top of your paper, as well as today's date. All right, let's get going with some definitions. Now, as we go through some of these, they'll sound very familiar. The intention is that some of this is a review. If you don't remember it, not a big deal, because we're going to go over it. So our first definition is quantity. Quantity is a word we use outside of math class, but our mathematical definition is we're going to say it's anything that can be measured or counted. So the quantity of pencils in this room, that can be counted. Let's take a look at the definition for variable. Variable is often generalized as just a letter, but the more formal definition for variable is a symbol, usually a letter, that represents the values of a variable quantity. Maybe take a moment to pause this video so you can jot these definitions down. To elaborate on that variable definition a little bit, it says a symbol, usually a letter. What we mean by that is you don't have to write this down, but often you'll see expressions like 2x plus 5. So it's usually a letter. But I could, and sometimes in higher math we use symbols, I could just make up and say triangle plus 5. It's a quantity that we're either going to solve for or find. So it could be anything. In the end, I would end up with maybe a 2x or an x equals a value, and here I might end up with triangle equals a value. So usually a letter, but could be just a symbol. And it represents the value of a quantity. Got a couple more definitions here. Again, when you need to, please pause the video. Numerical expression. A numerical expression is a mathematical phrase involving numbers and operation symbols, but no variables. A mathematical phrase involving numbers and operation symbols, but no variables. Now would be a good time to pause. Let's talk about this for a second. A mathematical phrase with numbers and operation symbols, but no variables. So that means it might be something like 3 times 5. That's numerical because it has only numbers, and it's an expression because it has an operational symbol like multiplication. Let's take a look at algebraic expression. An algebraic expression is a mathematical phrase that includes one or more variables. A mathematical phrase that includes one or more variables. Now would be a good time to pause. So when I take a look at this, a mathematical phrase that includes one or more variables might look something like 3y plus 7. It's algebraic, it has numerical values, it has an operational symbol, but now what's new is it has a variable included. So numerical means just numbers. Algebraic means it's probably going to have letters. Let's talk about algebraic expressions. In this example, it says, what is the phrase 5 minus a number d as an algebraic expression? Our goal in this example is to go from words to an expression. Okay, so we have to start off by making sure we understand what each word means. So let's go through the underlined phrase. 5 is just going to be 5. So that makes sense. Minus. What does the word minus mean? Subtraction. So you guys often use minus as the word instead of subtraction. So that makes it a little bit easier. A number D. A number D is a phrase altogether. A number D. So in this case, it's a number, but we don't know what that number is. It's represented by the letter D. So what we have here is our phrase, our words turned into an expression. 5 minus D is our algebraic expression. Let's try a few more examples. Now would be a good time to pause this video, take a few minutes to try these two on your own, see what you understand, and then we'll come back and go through these. Okay, so let's take a look. Something that I often like to do to help myself is to write symbols above or below the phrases. So for example, when I say more than is what type of operational symbol? Am I adding, subtracting, multiplying, or dividing? More than implies addition, so this would be a little plus sign. I also have 32, and I have a number n. Taking out that key piece of information, 32 more than, I'm adding 32 on to the value of n. So we took the words and turned it into an expression. Let's take a look at example 2. 8 times. What operation does times mean? It means multiplication. So 8 times a number n. So 8 times n. A quick review, sometimes that's hard to read. People might read that as 8xn, right? Sometimes that multiplication symbol needs to be written another way. So a better way to write that would be 8n. We know that when things are written next to each other, that implies multiplication. Some of you might have also learned that multiplication can be written as a dot. That would be okay as well. The best way out of these three options, though, would be to write it as 8n. Okay, to get going, if you leave it as times with an x, that's okay. If you're comfortable with a dot, that's okay. We just want to move towards having the number and letter written next to each other to imply that multiplication. Now, let's take a look at a few more examples. Now would be a good time to pause the video, give yourself some time to try these out, and then we'll see how we did. So let's take a look. Excuse me. First of all, we have to look at our operational symbols. We've got plus, minus, multiply, divide. Let's see if we understand what these words mean. The quotient. Quotient, what does that represent? That represents division of a number n and 5. So we're going to divide a number n and 5. You could write it as n divided by 5 over top, or I'm okay if you write it as n divided by 5. Let's look at the next example. 3 more than twice a number x. 3 more than, what does that mean again? Plus. 3 more than twice. What is twice? How do we find twice something? Twice something means we take it times 2, right? A number x. X is my variable. So 3 more than, we're adding on 3. 3 more than twice a number x. So add on 3, 3 more than twice a number x. Now instead of putting, if I say 2 times x, that can get confusing, right? 2 with a dot x, that's okay. But 2x, that would be ideal. So 2x plus 3 is my expression. Let's look at example 5. 9 less than. 9 less than. What does that mean, less than? What am I going to do? I'm going to subtract the quotient. What does quotient mean again? We already used quotient, division of 6 and the number x. So 9 less than. So I'm going to subtract 9 from what? From the quotient of 6 and the number x. So 6 divided by x, subtract 9. Let's go through that one more time. 9 less than the quotient of 6 and x. Okay, when we're dividing, we're just going to read that in order. If 6 comes first, it goes on top. X comes second, it goes on bottom. Now let's try the reverse. What if you're given the expression and you need to write it into words? So let's go through this example together. The expression is 3x. Okay? So we're going to use our vocabulary to write a sentence. We're going to say 3 times a number x. So now it looks like the previous examples. If you look back up to those examples, you can use those to help you with your vocabulary. So I can double check. I've got 3 times a number x. That would describe this expression of 3x. All right, let's take a look at some more examples. What I'd like you to do right now is to pause the video so you can try a few of these on your own, and then we'll come back and we'll do them together. All right, let's take a look at the first example. It says x plus 8. So I want to write that in words. So when I have addition, if you look at our previous examples, you'll notice that was always written as more than. So how many more than do I want to add on? I want to add on 8. 8 more than the number x. You'll notice we always wrote the number before the variable because we just want to clarify that that variable represents a numerical value. So 8 more than the number x. Let's take a look at example 2. It's addition again. So let's start this phrase the same way we did the last one. I'm going to have 11 more than. So I took care of the plus 11, but now I've got 20 times x. Listen to how I said that. 20 times x. So 11 more than 20 times the number x. Okay, so we can say the word times. I'm okay with that. And we have the number 20. You don't have to write out the words for the numbers. You can just write the digits. 11 more than 20 times the number x. So you're going to see this phrase, the number, in all of these because they all have a variable. Let's take a look at example 3. This time I'm subtracting. So subtracting uses what keyword in our previous examples? Less than. So I'm going to say 1 less than. And then we have 5 times x. So 1 less than 5 times the number x. So again, we've got that number phrase before our variable. All right, next we have a division bar. So if we look back at our examples, we use the word quotient to describe division. So in this case, we're going to say the quotient of 18 and the number n. So we're just going to keep writing the number before our variable. So the quotient of 18 and the number n is how we would write that. You'll definitely want to make sure that these, if you did do them on your own, make any corrections that are needed so you can use these examples when you work through your homework. All right, let's take a look at a few more examples. In these examples, we're given a scenario and we want to write a rule for the problem. So in this case, we've got a table and words to describe our situation. So let's read through. It says Dorothy gets paid to walk her neighbor's dog. For every week that she walks the dog, she earns $10. Using the table, create a rule for the pay. Give the rule in words and as an algebraic expression. So she earns $10 a week. So if I look at the table, at week 4, they jumped ahead a little bit. She made 40 bucks. Week 5, now she has a total of $50. After 6 weeks, she then has a total of $60. So how can I write that as an expression? What are we doing to get from 4 to 40, 5 to 50, 6 to 60? So here's what we kind of want to think about. If I look at the table, I'm very visual, so that table is helpful. What rule are we doing every time to those numbers to get from here to here? Take a moment, pause the video, and talk with someone nearby or think about what's the rule? How do we get from one to the next? All right, so if you figured it out, to get from 4 to 40, we had to times by 10. 5 to 50 times by 10. 6 to 60 times by 10. Where do we see that times 10 in the problem? Right here, she earns $10 for times every week. So we see that rule in the description. So keep that in mind. You should see it somewhere in the writing. So let's use some variables and the rule to write an expression. Use these letters that represent weeks and pay. So in this case, we are taking 10 times what week we're in. So if we're in week 6, we take it times 10, she has a total of $60. If we take 10 times week 50, we would end up with how much money she made after 50 weeks. So this is our algebraic expression. Okay, it's going to look like all the examples we've already done. So keep that in mind. Look back at what the other problems look like, and that's what this should look like. But it also says in words. So in words, we want to write that out. We're going to say 10 times a number W. W's are variable because that's what they're using in the problem for weeks. So when I look at these questions, I'm going to look for the expression, also in words. Let's take a look at one more. So this time, I want you to pause the video, try this one on your own, and then we'll come back and go through it. All right, hopefully you paused and tried this out. Let's take a look. It says the cost of beverages in a vending machine is shown. Write a rule for the cost in words and an algebraic expression. So the first thing I want to try to figure out is what is the rule? How are we getting from this number to this number? Well, in this case, I'm timesing it by $1.25. 2 times $1.25, 3 times $1.25. If I was to keep going, the pattern would be consistent. So I'm going to say, instead of beverages, I'm going to use the variable B. So my expression would be $1.25 times B. You don't need a dollar sign in here because it's an expression. A dollar sign would be a label for the final answer, so we don't have to include it in our work. But now we also have to write it in words. So I would say 1.25 times a number B. That would be my words, and this would be my algebraic expression. Oops. Pretend there's an I in the middle there. Okay, so now this rule would be true. If I was to write out times 10 beverages, 35 beverages, 50 beverages, this rule would work for all of those options. So today we're going to work on a worksheet for practice. Everything on the worksheet is like what we have worked on in this video. Since this video is available to you on YouTube, I do expect that if you get stuck, you can pause, rewind, rewatch an example while you're working on the worksheet. So that can help. If you're like, I forget how she described this, go back to that example and replay it while you work on the worksheet. Okay, let me know if you have any questions, try your best, and we'll go over any last few questions when we meet next. Alrighty, so have a good day and we'll see you next time.